At this point, if the shot is only seen from above and never shows the underside, then this rig is pretty much complete. But if our shot will show these chassis parts, then there are more details we can add. Let's take a look. For example, if I lift the wheel, we'll see the parts connecting to the wheel are not linking up well with the wheel itself. This is very obvious in the front. It's also obvious in the back. This rod that should be connected to the center of the wheel is currently moving up and down with the car body. In this section, we're going to rig these parts. Before we actually start rigging, let's first look at their connections, analyze these parts and how we should rig them. To make it easier to see, I'll switch it back to the default material display, then show the wireframe. Then let's take a look. We know the front wheel's up and down movement starts from this point. This entire area will move up and down together. And this rod in the middle is basically a line drawn between these 2 points. So let's think about this. When the wheel moves up and down, the wheel, along with that small part we drew, will move up and down together. This rod needs to stay connected at one end to the left part and at the other end to the right part. So here it's actually doing this kind of motion. Its position should be the center position of these 2 points, and its rotation should always be aligned with the line drawn by these 2 points. It's roughly this kind of effect. I'm sure we're all very familiar with this structure. When we did a little exercise on controlling the car body lift with 4 points, we talked about using 2 points to control a rod's lift. This rod for the front wheels, doesn't it perfectly match that basic exercise we did? So we'll use the same method to rig it. It's actually the same for the rear wheel. The rear wheel just uses the wheel's own center point as the starting point, and then a line is drawn. So when this point moves up and down, it's the same structure, the same rig. And here, let's see if there are any other parts. We'll notice this part at the front wheel. The other end is connected to the car body itself. They have a rod in between. So here we need to find a point on this front wheel rod. And the other point is this point on the car body. And then we'll set up this rod. It's the same for the rear wheel. We'll see a part on the car body here, a part on this rear wheel rod here, and the line between them is the same method. Find a point on the car body, find a point on this rear wheel rod, and then connect this rod in the middle. The chassis parts here aren't too complicated. I've simplified them to some extent. If we encounter more complex car parts in the future, it's still the same process. Analyze them part by part. Then set up the main parts first, and then one by one take the secondary parts and set them up based on the main parts. Next, let's start rigging the chassis parts. First, let's start with this rod connecting the 2 front wheels. We've mentioned this before. It's exactly the same as the little exercise we did. First, we need to find the positions of these 2 points at the ends. We've already found these positions. They're just the positions of the 2 steering locators. If we remember, when we were controlling the steering, we actually created a group here, and used this group to control the steering. So this group already represents its position, and when we move the wheel up and down, this group will follow. It will also move up and down. So we can use this group from the left wheel and this group from the right wheel to control this middle rod. First, let's create a locator. We'll name this locator based on the rod's name. Then let's group it, a 0 group. Then find the group that controls steering, and find the one on the right. Select these 2 groups, then select the 0 group. Or we could also select these 2 locators we use for positioning. Select the 0 group, because here we just need to find an initial position. Do a point constraint, no maintain offset, then delete the constraint node. This way, our locator's parent 0 group is snapped to the position between the 2 wheels. Next, we can use the 2 groups we created that control the wheel's rotation pivot to apply an actual point constraint to the locator. After we do the point constraint, let's check. This locator's position is now in the middle of the 2 wheels. Next, we need to do an aim constraint. We should be very familiar with this. the x-axis points to the left wheel's position. The question is, which up axis do we use as a reference? Since this is a rig, we can't use the word y-axis as a reference anymore. Because our car might have, for example, a 180-degree flip. In that case, this rod's up axis, if it flips 180 degrees, will point down. If we always use the word y-axis as a reference, our rig will break. So here we need to study our rig. For example, if our car does a 180-degree flip, which axis can represent the roof's position? A position like this. Imagine if it flips 180 degrees. Our roof will be at the bottom. It will point down. We need to use that direction as our up reference vector. Let's take a look. First, let's look at the cog controller. The cog controller's y-axis is pointing up. If we rotate it 180 degrees, it is indeed consistent with the roof's direction. But we must be careful here. Our front controller can also do the same operation. If we use the front controller to flip the car, then the cog controller, having no rotation, its y-axis will still point towards the word up. It's not in the same direction as the roof. By the same idea, our back controller can also do the same operation, so we can't use the front controller either. The back controller is the lowest level one of these three. Can we use this controller as the reference? We should be able to, because the car body controller further down is this suspension controller. And this controller, its range of motion is very limited. It's impossible for it to flip 180 degrees. So let's use the back controller as the reference object. Let's copy its name. Then find that group controlling the steering. Then find the locator. We're going to do an aim constraint. We're still using the x-axis to point at it. So the aim vector is 1, 0, 0. The up vector will use 0, 1, 0. The word up type select object rotation up, because we need the back controller's y-axis direction, not the back controller's position. In word up object, enter the back controller's name. This way, when we move up, we'll see this locator will have a corresponding rotation value. It will stay aligned with the line connecting these 2 points. Next, let's create a trans group to control the model. Let's do a parent constraint. Turn off maintain offset. Then find the corresponding model. Put it under as its child. This way, let's check. We'll see this rod is now connected to the car. We'll see here, when it moves beyond a certain range, there will be some gaps. This is unavoidable at the moment. First, in reality, a car wouldn't have such a large range of motion, so a small gap here is normal. Generally, in this situation, animators also need to be careful when animating to make sure its range of motion isn't too exaggerated, because that's also not realistic. Another point, if we want to connect them, we would generally add extra deformers to connect them. But deformers are beyond our current scope of knowledge, so we won't go into detail here. Okay, let's zero out the controller. This way, the rigging for this front rod is done. Let's put the locators group and the model's trans group in the right hierarchy. This rod should be at the same level as the wheel's up-down controller. The wheel's up-down controller, what is its parent object? It's the back controller. So let's also put the locator under the back controller as its child. And put the model's trans group in as well. Put it under the rear model's trans group. This way, let's check. The front rod is now done. Using the same method, let's do the rear. For the rear, it doesn't have a steering system, so its center point is just the wheel itself. That is the two wheel controllers. Let's create a locator. Same operation, copy the name and change it. Then use these two controllers to apply a point constraint to the zero group. Then delete the point constraint. And then use these two controllers to apply a point constraint to the locator. Next is the aim constraint. The aim constraint is the same here. The x-axis points to the left wheel's controller, and we'll use the back controller's y-axis as the up vector. Select the controller, select the locator, then aim constraint. The settings should be exactly the same as before. This way, let's check. This is the result we want. Next, create a group. Then do a parent constraint. Then parent the group above the model. This way, let's see, the effect in the rear is also done. Next, same as before, put the corresponding nodes under the corresponding groups. The locator's 0 group goes under the back controller, and the model's trans group goes under the main model's trans group. Okay, so the front and the rear rods are now set up. Next, let's do the device that connects the rod and the car body. Let's look at this. It's split into two ends. This side is one end, this side is one end, and a rod in the middle. This rod might have the same problem as the rod connecting the wheels. When it moves too much, there might be some gaps in the middle. This gap is unavoidable for now. We have to make a trade-off here. Where do you want this gap to appear? When the movement is too large, do we want the gap at this end or at this end? Or do we want the gap at both ends, but the gap distance is more averaged? This depends on our own trade-off. There's no right or wrong. I'll choose to have this rod stick closely to the front part. If there's a gap, it will appear at this rear car body position. Let's do it. First, we need to determine the center point positions of the two ends. Let's start from this side. This part's center point is definitely this vertex. Let's create a locator. We'll call it center front connection bar pivot car. Then turn on wireframe display. Snap the locator to this vertex. This way we found the center point on this side. Next, let's find the other side. Let's duplicate it. Snap it over as well. Okay, so the positions of both points are found. Next, we need to do an aim constraint. We can just use these two locators, because we know we probably won't need this position information again. Let's group each of them. Then snap this group over. Snap it to the same position. Then parent it. Now let's see how to control it. First, this is the rotation pivot. We need to see what controls its position. Its position is controlled by this rod. It's connected to this rod. So we need to put this locator under the hierarchy of the locator controlling this front rod, which is this locator. Let's parent it under as its child. This way, look, when I move it, this rod connecting to the car body, its pivot point will also move along with the rod connecting the wheels. This is the effect we want. Then let's look at the other locator. This locator moves with the car body. What controls the car body in the end? It's controlled by this suspension controller above, right? When it moves, see, the car body moves with it. So we need to put it under the suspension controller as its child. Let's parent it and see. Okay, next we need to do the aim constraint. We need to use the car body locator and this other locator to do an aim constraint. But we need to analyze this. What should we use as the up vector? Let's look at its up direction. It's clearly this direction. The aim vector is definitely pointing towards the car, and up is still towards the roof. But because it's connected to this rod, if this rod's up direction changes, for example, if this rod rotates, it will become like this. This is the part we are connected to. Its up vector should also be in the same direction and no longer pointing upwards. So based on this logic, we'll use this rod's locator as the up reference object. Let's find this rod's locator. It's this one we created earlier. Let's copy its name. Then find this side's locator. Find this locator we just created and do an aim constraint. We'll see its default axis is not quite aligned with the axis it should be pointing at. We have a few choices here. We can directly apply the aim constraint to this locator. This locator will then have some values on it. These values don't matter, because we just need it for the connection. There are no further operations. But if we have a personal preference like me, I generally, when doing these setups, prefer to ensure that when the locator is constrained, its own translate, rotate, and scale are at default. I prefer to put these offsets onto the 0 group. If that's the case, then just like when we snap these locator positions, we first apply a constraint to the 0 group. After deleting it, we then apply a constraint to the locator. Following this logic, let's first apply it to the 0 group. Let's see. We'll still use the x-axis, then y-axis. As for the reference object, it's that front rod's locator. Then create it. We'll see the 0 group's rotation has changed. Let's delete the constraint node. Then redo this constraint. This time, we constrain the locator itself. Let's create it. Now let's look. When we move up this locator, we'll see its x-axis is still pointing at that position, and its y-axis is aligned with the rod's orientation. Next, we need to create a trans group to control the model. We'll just parent this rod's model. Because these two ends won't rotate, they will move with this rod. We need to fix this in a moment. Let's parent this model first as its child. Let's check the effect. Now this rod moves along, but this model isn't moving with it yet. We need to take the group above this model and put it under the group that controls this rod as its child. This way, let's check again. Now it has a proper connection behavior. Take a look. Next, let's put the model's trans group under the group it should be in. Let's check again. The front parts are all set up. Next, let's do the rear setup. It's the same operation for the rear. Let's see. One is the locator here. Snap it over, and the other one is over here. And same operation will create two 0 groups. Snap their positions. This way, we have the positions of the two locators representing the vertices. Next, we need to do the same operation on them. This end's locator should be parented under the locator that controls this rod. Let's find it. It's at this position, parented as its child, and the other locator is parented under the suspension controller as its child. Next, we'll first do an aim constraint on the 0 group. Find the locator above that locator. Let's copy its name, because we need to use it as the up reference object. Find the locator representing the rear vertex, and this one we just created. First, select its 0 group, then aim constraint. Change the up reference object. This will give us a new value. Delete the constraint node, then do the same operation, but this time constrain the locator itself. This way, the rear is almost set up. Create a group. Change the name, then do a parent constraint, and parent this rod's model as its child. Then same operation. We also need to put this group in the proper position, which is under this rear rod's group. Finally, put the model's trans group under the corresponding group. Then let's look at the result. These rear parts are now linking and moving together. This way, our chassis parts rigging is complete.